All right. Hi there. Today, Algebra 2, I'm going to be covering Chapter 4-8 and 4-9, finishing Chapter 4-8, and then doing Chapter 4-9. So the first one says find all solutions. All. Now it doesn't say all real solutions. It says all solutions, which means I'm going to probably need some imaginary numbers perhaps in there. All right. So that when you get a square root of a negative number, you're no longer done. In other words, you got to actually do it out. So A is what's in front of the x squared. There's an implied 1. B is 2. C is 5. Okay, plug those numbers in your quadratic formula. You get negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That will equal x. Okay, so negative 2 plus or minus 2 squared is 4. 4 minus 20 all over 2. So quickly I'm getting down to x equals negative 2 plus or minus the square root of negative 16 over 2. Now, a refresher over here. Remember, I'm looking at square root of 16, negative 16, which means I'm going to get an imaginary number. Okay, so here I got the square root of 16 times the square root of negative 1. And a reminder that the square root of negative 1 is I, okay, the imaginary number, the variable I, which means the square root of 16 is 4, and that's I, which is what I'm getting here. So now I'm going over this direction. X equals negative 2 plus or minus 4I over 2. Now this can also be reduced because all three of these numbers, the coefficients, are divisible by 2. There's a couple ways you could look at it where I pull out a 2. If I pulled out a 2 here, I would get negative 1 plus or minus 2I over 2, and then those cancel. That's one way to think about it, okay? Or you can just divide all three of those things by 2. Either way, you get negative 1 plus or minus 2I, okay? And that's what x equals. I should put that there, okay? There's the first one. Second one, same idea, just different numbers. A is 2, B is negative 3, C is 5. Plug those into the quadratic formula. So when I plug in a negative number for negative B, it becomes positive 3. You would have had a double negative, which would have canceled out. So I got 3 plus or minus the square root of b squared, which didn't like that 3, in parentheses. That front one's always positive once you're done squaring it, times 4 times a times c all over 2 times a. Alright, so I didn't give myself much space on this problem. So that's 3 plus or minus the square root of, so that's positive 9 minus 8 times 5 is 40 all over 4. And when I go 9 minus 40, that's 3 plus or minus the square root of negative 31 over 4, which means you're going to need to reduce this, okay, and turn it into i's. You should have no negative numbers under the radical by the time you're done, which means this is 3 plus or minus the square root of 31 and I, okay, all over 4. Now sometimes you might see this as 3 over 4 plus or minus the square root of 31 over 4I. That's the same thing, just written differently. I just put both of the things in the numerator over 4. That's it, okay? And you're done there. I mean, if they ask for decimals, which they usually don't, especially when it's imaginary numbers, you take the square root of 31 and divide it by 4. 0.75 is 3/4, okay? This one is a little different. Save that you try for a minute. Factor that. So this one, it's like x squared minus 16. You got to keep in mind here that, if I was to factor this one, this would be x plus 4 and x minus 4. This one, if I was going to factor it, it's similar because it's x plus 4 and x minus 4, but there's a little bit more to it. Because you have to put an I on both of these. Okay, so this is actually the answer. And if you want to check this by FOIL, this is where it probably gets interesting. I get x squared plus 4xi minus 4xi minus 16i squared. Okay, and then of course these two cancel out, the plus 4xi and the minus 4xi, which leaves me with x squared minus 16. I squared is negative 1, which means it's really x squared plus 16. All right, so there's your checking, but that's what you get. Okay, so if I ever give you that factoring, I'll expect you to be able to throw the i's on there. Same x plus 4 and x minus 4. Throw the i's on there. Okay, so this one, I want you to try this. Find all the solutions. X squared minus 3x plus 3. I'll be kind and give you the answer. There you go. You can see that you got it right, but show me the work in class if you want full credit. And then I'm going to move on now. That was a quick finisher-upper on 4-8. Now I'm on to 4-9. Quadratic systems. A system of one quadratic equation and one linear equation can have two solutions, one solution, or no solutions. And here are three graphs to illustrate those three situations. So you can see, you're looking at the points of intersection. How many points of intersection are there? If it hits the two intersections, or like this over here, that's two solutions. Over here, it hits that line and the curve intersect at one point. You can get that, or sometimes they may not intersect at all, in which case, there's no solution there. All right, so those are your three different situations for what's coming up. Now, this stuff is actually, I find it pretty easy. They throw a bracket on here so those two equations go together, but I do these pretty much all of them by substitution, which isn't the only way, but it's the way I seem to like, which means these two things equal y, which means I can substitute in the x plus 3 for that y, which means I get x plus 3. You're actually taking these two things and setting them equal to each other. X squared minus x plus 6, okay? Which is a pretty easy equation to solve. In fact, we've been doing things not too unsimilar from this. So anytime you got a big quadratic equation like that, bring everything to one side, and then factor and solve, or quadratic formula and solve. You could graph, although that's not usually the technique of choice. So if I do this and I bring everything to one side, say I subtract x, I'm going to do it in one shot here because we can do this now, right? Both of these cancel. I get 0 equals negative x squared minus 2x plus 3. And then you can choose which way to solve it. I'm looking at that x squared and I'm thinking, if I can pull that negative 1 out, this will be maybe really easy to factor. I got positive x squared, positive 2x, and then minus 3. I just changed all the signs inside the parentheses. And now you can actually get rid of that negative 1. Divide both sides by negative 1, and 0 divided by negative 1 is 0. Which means I'm just looking to factor that parentheses there. Things that multiply to negative 3 and add up to 2. That's x minus 3 or x plus 3 and x minus 1. Yeah, there we go. That's the winning pair. Which means my answer is going to be x plus 3 equals 0, x minus 1 equals 0. And then subtract 3 from both sides. I get x equals negative 3. Add 1, I get x equals 1. Now here's the thing students always forget. I need to find the y coordinates. So I'm not done yet, okay? Let me write that down in red. Need y coordinates. So I've got the x equals negative 3. Which means I'm going to take, one of the original equations, okay? Take the easier one. The easier one is always the linear one. Y equals x plus 3. Y equals x plus 3. And then plug in the negative 3 there. And you get your y coordinate, okay? So my answer is actually negative 3, 0. Because remember, you're looking for the intersection points. Now I'm going to take the other one, the x equals 1, and I'm going to plug it into the linear equation part. So this goes in there, y equals 1 plus 3, so y equals 4. So that's x is 1, y is 4, and these are the answers, okay? That's how you do these. This isn't bad at all. Number 2, same idea. So I'm going to set them equal to each other. I'm going to go 2x minus 3 equals x squared minus 2x minus 3. Bring everything to one side. I'm going to subtract 2x and add 3. This is going to be nice because all that stuff cancels. A lot of stuff cancels. I get minus 4x, and both of those cancel. So this is great because this is going to be a piece of cake to solve. I can factor out an x. So x times x minus 4 equals 0, which means two things, either x equals 0 or x minus 4 equals 0. Add 4, I get x equals 4, which is great. All right, now remember, I got to find the y coordinate, so we can pick one of those two equations to work with. If you want to do a ton of work, pick the quadratic. If you want to do a little bit of work, pick the linear one, y equals 2x minus 3. Y equals 2x minus 3. Y equals 2x minus 3. Plug in x is 0 here. So y is negative 3. So that's 0, negative 3. There's a solution. This one, x is 4. 2 times 4 is 8 minus 3 equals y. Y equals 5. So my point is 4, 5. And there's my two answers, okay? That's how you do these, all right? I got a you try. You try this one. Y equals negative x squared plus 2x plus 18, and y equals 5x plus 10. Don't forget to get the y coordinates, please. I was kind and showed you the answers here so you can see if you got it right or not, okay? And that is it for the moment. Okay, so here's my last problem. So, once again, these two things are equal to each other. I can take the x plus 5, substitute it in there for y. So I got x plus 5 equals negative x squared minus 3x plus 10. Bring everything to one side. Subtract x, subtract 5. You can do it in 2 moves if you like. I get 0 equals negative x squared minus 4x. Positive 10 and minus 5 is plus 5. And then, let's see, if I pull that negative 1 out, I get positive x squared plus 4x and minus 5. Oh yeah, that looks good, because then I got 0. One of my factors is a negative 5 that add up to 4. That's x plus 5 and x minus 4. Because they multiply to negative 5, add up to positive 4, so therefore x plus 5 equals 0 or x minus 4 equals 0. Therefore, I get x is negative 5 or x is 4. That's a lousy 4, but that's a 4. All right, so those are my two answers. But remember, I got to get the y coordinates, so I'm going to pick the easier of the two equations, which is that one, y equals x plus 5. So when I take that, and I'd go negative 5 plus, oh no, what happened? Okay, so I'm back to here. I brought everything to one side, substituted in, brought everything to one side, and then factored the x squared plus 4x minus 5, and I got x plus 5 and x minus 4. Oh, that's wrong, isn't it? Because 5 times 4 is 20, not 5 and 1. X plus 5, x minus 1. Fix that. So that's 4, which means x equals 1. Why do I keep writing 4? 1, 1. Okay, so now I'm plugging the values into the linear equation, the y equals x plus 5. So x is 1, so y equals 1 plus 5, which is 6. So x is 1, y is 6. If I plug in negative 5 for x, I get y is 0, so that's negative 5, 0. And those are my two answers. Okay, and that was the last problem I was doing here. I'm going to close it out.